Today, we are going to understand what is the stage table, what is the use of the stage table, and then how can we design it, design consideration of it. First of all, we try to explain this is a OLTP database, daily transaction database. Behind our operation, we have this database system. It is also a relational database system, and it is normalized database system. If you look at this structure like that, it has some relationship between, for example, between this table and this table, there is a one-to-many relationship. Between this table and this table, there is a one-to-many relationship again. Between this table and this table, there is a one-to-many relationship. Today, we will mention about this stage database. Stage database is actually temporary location. Temporary location. And exactly same structure, same design with this one. A little bit, there is some different consideration. And why we are going to use stage database? To transfer our data from here to here, we will use this stage database as a temporary. First of all, we will load our data from here to this place temporarily. After, when we do some transaction and when we do some transformation operation, we can add final data to the data warehouse system. And let's see a little bit difference between them to remind what is happening. So database, as you know, it is a structured data. We can consider database as a structured data or categorized data. Yes, specific definition of it is a structured or categorized data because if you look at the one database table, it is a structured. For example, in this table, there is a product ID column, product name column, price column, and category ID column. There is a structure of this table like that. In this table, we have customer ID column, customer name column, and city column. We have structure of this structure in this data. That's why we are calling these ones database system or database tables. It is a structured data. It is categorized into the groups or columns. For example, class list is a very good example, simple database. Yes, if you ask what is the simplest in this word example for database system is a class list. If you look at one class list, you can see all information categorized according to the student number, student name, student surname. It has minimum in one class list. Minimum should have three structure or three columns or three groups: student numbers, student name, and student surname. Three structure or column. Data warehouse, we will mention it later. What is the difference between data warehouse and database? A typical database is designed for OLTP, online transaction processing, such as listing, deleting, updating. If you look at our example, last week we have designed online sales, I think this one, yes. We have this database system, yes, shopping, tables, category master, category customer master, product master, and sales master. If you go Solution Explorer, we have one application. Let's make it startup project and let's run. not this one, form application, this one. We have, if you remember, we have 3 projects in that one. Set as and run. Before running it, let's choose this place. Views, sales, index. This is our sales table. If you want to make new sale, for example, you are making one online, you have one online sales company and you are selling some things, yes, and you are making sales. For example, you want to make new sale. For example, you want to sell one ice cream, for example, yes, and to whom you are selling? To John, for example, and then sale date, you can enter one date, quantity, how much you are selling, sales amount, how much, and deliver date, and great. And these sales will be located in your database. Which database? In this database. It will go into this date. This means what we taught in the definition, online transaction processing, such as listing, deleting, updating, yes, in your database, OLTP. If you are making this OLTP process, listing, for example, deleting, updating, adding new, and you can go to your website and you can, for example, you can delete, you can see the details, for example, listing. You can see the one of your sales, to whom you did sales, what did you sell, in which date, you can see this list, or you can delete one of your, this is all online transaction. But online doesn't mean here like that internet. If because 20 years ago, don't confuse it, 20 years ago or 30 years ago, online means, doesn't mean today's online internet. Today, when you, if somebody tell you online, you will understand internet application, yes? But this online here doesn't mean internet connected system. This means directly connected to the database system. Because 30 years ago, there were no like that internet systems, yes? Your application, this application connected to the, directly to the, this one. Let's see. For example, we can also have form application, like a Windows application. Let's make it startup project and let's run it. This application is running from my desktop computer, and database also can be in my computer or can be somewhere in the network, in my computer network. For example, 30 years ago, think you have one database staying in the network somewhere, and you are connected from here. This is also 30 years ago. It was called online system, but this is now not online system. Actually, when you tell today online, if you can access your database through internet, we are calling it online. But 30 years ago, online has different meaning. Online means if you can connect directly to your database or through network, computer network, it was also considered as an online system. But when you tell today, meaning of online change completely. Online means any system connected to the internet. So a data warehouse, opposite to this one, a data warehouse is designed and optimized for online analytical process. We will learn this one later more. What is this online analytical purposes? For example, data visualization, data reporting, data mining. This means to analyze your data. If you want to analyze your data, actually you need data warehouse system. But if you want to make daily process, for example, if you want to add new record, if you want to delete one record, if you want to list the record, you need traditional database system. Now these definitions, I think they are becoming more meaningful because of we have designed already this type of this system in the last week, sorry. For example, database designed to handle operational data. What does it mean, operational data? Operational data means it is not analytical data, operational data. Operational data, we thought like that, for example, it is an operation. You are operating your system, you are operating your business. When you are operating your business, you are producing some data. For example, when you sell a product, you are producing new sale date, customer name, product name, sales amount, quantity sold, new data you are producing. Your system producing new data. An example of the operation data source. For example, this shop is not online shop. It's the one of the shopping mall. When you go to one shopping mall, for example, when you buy something, and then they are going to give you receipt, check. Yes, these all sales through these barcode systems producing new data. Yes, online database is designed to handle operational data and transaction. We told in traditional database there is 4 basic transaction. You can either add new record, you can list existing records, or you can delete one record, or you can update one record, something like that. Transaction, you are going to do transaction. Data warehouse, opposite to the database, data warehouse is designed for analytical purposes. We haven't designed data warehouse system for now, but we will design in the next coming weeks. We have designed now this one, and we will design today this one. We are revising this one. Now these definitions is more meaningful now for you. So data warehouse system include extraction. Extract means to select some of data, not all data. Transportation means transfer your data from one place to another place. Transformation, to change your data format. For example, if your head of company for example, in the United States, and if one of your company in the Europe company, they are using centimeter, for example, yes. When you take when transfer your data from Europe department to the US department, to make the report meaningful, you should transform any measurement made in the centimeter or meter to inch. Yes, it's a kind of transformation. And loading, and your loading operation, we are using all these things for data warehouse. Later we will learn more about it as I thought. But in the database system, we have simple CRUD operation. CRUD means to create. When you want to create, what are going to do? You are using insert. Actually, you are going to use insert query. Yes. Read. If you want to read some data, you are using actually select query. You are going to use select query. And update operation. You need to use update query. Delete operation, you need to use delete query. In the database system, we have basically these ones. You already know these ones from the last year. First of all, now we understand up to now, if you have designed one database, actually you have designed relational database system, and then we are calling also it is a OLTP, online transaction processing system. We are calling it as also online transaction for this type of database system. Yes, when you design data warehouse, it will be OLAP database system. Traditional database also use this one, or operational database. Yes, also we are calling this database operational database, because this database behind our business. Yes. In your system, you can have this database. You can have in professional design enterprise database management system should contain all these parts. But actually, behind your running business, there is this database system. Yes, you are interacting with this database system. You are not ordinary users, sellers who has job to sell something to the others in your company. They are all interacting with this one. And then executive managers in your company who wants to see the results, how is going processing, how is what is the amount of those sales. They will interact with this database. Analyst who is making analysis in your system, they will interact with this database. Ordinary users, they are not interacting with this database. They are interacting always when they make one sale, if they want to add one customer, if they want to delete one customer, if they want to update some information about customer. By the same way, for example, if you are managing university management system, if you want to add new coming students, you are adding all these students into this database system. When the exam results come out, for example, one professor, if he wants to add final exam scores to the system, they are always adding to this operational database system, or OLTP database system, or operational database system. This database system staying inside the database server. In our example, our database server is a Microsoft SQL Server. You can use another database management system. And then stage database, we are calling it temporary data location. This means what are there inside this table, and from this database to which data you want to transfer to this database. Temporarily, we are first transferring into this database. Temporary location. First, we are transferring our data. If you want to transfer some of your data from here to here, we are firstly transferring our data to this place. That's why we are calling it temporary data location. Again, this database system is staying inside the database server, inside the Microsoft. In our example, it will stay SQL Server. For now, we are not interested with these ones, but later we will be interested with them. Also, data warehouse will stay Microsoft SQL Server. It is in SQL Server. Its name is OLAP database or data warehouse, you can call. It is a analytical purposes. We are using this database for analytical purposes. That's why you can also call this database analytical database. It is also staying inside the SQL Server. These data cubes, we will learn them more later. We are calling it data cube or OLAP cube, online analytical processing cube or data cube. They are staying different server. They are not staying anymore in any database. Yes, OLAP server. For example, if you design you can design this one inside the MySQL database server, but you cannot design these data cubes in the MySQL because MySQL doesn't have OLAP server. But SQL Server has also OLAP server. Name of the OLAP server in the SQL Server is a Microsoft Analyze service. Let's see. Maybe you didn't realize up to now, but when you install Microsoft SQL Server on your system, actually you have also OLAP server in your system. For example, when you click this one, you are going to connect to the database server. You are going to the database server. Yes, you are going to database server, But if you want to connect to this OLAP server, its name is in Microsoft SQL Server. Its name is a Analyze server. If you want to connect to that server, you need to select here Analyze servers, and you can connect also another server. This is a completely another server. Yes. Now it's connected to Analyze, Microsoft Analyze server. Now we have connected to Microsoft Analyze server. Yes. Its name in different places. In different places it is called sometimes OLAP server, but in the Microsoft it is called Analyze server. Actually, Analyze server is a type of the OLAP server. Yes. Up to now we have connected to this server. Now, last week we have designed this database system. This week we will start to design this one. That's why which server we should connect. Again, we should connect to the Microsoft SQL Server. This means database server. Yes, that's why we don't need to connect this place for today. We need to connect database engine, database server. Yes. And when we connect there, we will see our shopping DB already designed there. Shopping DB, we should see that our shopping DB we have already designed. Yes, this database. Today we are going to design this database. We have designed this one. Today we will design this database, stage database. So we thought it is easy. If you know, if you pass database course last year, you can understand this topic very easy. This database system, we thought relational database is a normalized database. Last week also I explained what is the aim of the normalization. It is exactly the same. If you have designed this database, also you can design this database. But there is one consideration. What is this consideration? We want to load our data from here to here. To make this loading process easy, this is important. This is important. Most of the people, they are missing this point. Since this is a temporary location, look at this is temporary location. We will not use this database as a main database. Our main database, operational database, this one. For when you make one sale, when you add one customer to your system, always you are adding original data staying here. And later we will get some of this data to this place. Why? We will load from here to here. Why we will get this data, load some of our data from here to this place? Because we want to make some analysis. We have explained last week. I have explained last week, if you remember. If you make some analysis in this database, it is going to give you wrong results. For example, we have done that example. I want to see how much amount of the product I have sold to the Bishkek. Yes. When you get to this result, you are going to see you are getting wrong answer because of some customer updated their location. When you updated location, how it is update process working? Update process working like it. For example, when you go to, for example, let's go our customers. And run our application. For example, if you want to update first customer, Hassan. If you want to change this one to do Bishkek, for example. Bishkek. When you save, what is happening? Istanbul deleted and Bishkek come to it. Save. Yes. Now Hassan, now not anymore from Istanbul, our customer. He is our customer from Bishkek. Because edit process allowing it. But how edit it is working? Behind the edit button, there is a insert query. How insert query is working? Insert query is overwrite, delete Istanbul and overwrite instead of Istanbul, Bishkek. Overwrite, yes, it is not going to keep historical data. This means for example, now, if I want to get report, what is the sales done for the Bishkek, I will get the one result, but it is wrong because Hassan before he was not our customer from the Bishkek. He was our customer from the Istanbul because up to today, any product we have sold to him, actually we have sold it to the Istanbul, not to Bishkek. That's why if I will get one select, if I will execute one select query if to see what is the amount of the product we have sold to the Bishkek, it will give us wrong up starting from today. This query will give us wrong data. Yes. In the database, operational database system, we cannot get rid of these mistakes. If you want to make correct analyze, if you want to see correct result, we should work with data warehouse system. So we told this is a temporary place, this is the original data source, and if you want to analyze your data, you should bring original data from here to the temporary location, from temporary location to this place. Since this is a temporary location, and since we will bring some data from here to here, this means we will load data. Look at how we will load. We will use ETL tools. If you want to load your data, because you don't need to enter all data here manually to here again. Because, for example, your business running every day, and every sales producing, generating new data. For example, after 1 year, you will have million records. At the end of the year, if you want to analyze your data, you should not enter all data which you get from the running business to do this place manually. How we'll do, instead of entering all this data manually in this system, we will load this data to the here by using ETL tools, extract, transfer, and loading tool. We will use this tool. Yes, also we have for this one tool. Its name is in Microsoft SQL Server, its name is integration service. By using integration service is a professional enterprise ETL service. You can use this service to transfer your data from here to here. But before transferring your data from here to here, you should make exactly same clone of this database. But there is one problem now. What is that problem? Constraint. In the last year, in the database system, we have seen this constraint. If in our design, if you look at in our design, we have primary key, we have here primary key, and here we have customer ID is a foreign key, because we told is a foreign this table, because customer ID is a primary key in this table, but customer ID is a foreign key in Astronet or yabancı in Turkish, yes, or Russian in Astronet key here. There is a foreign key here. Also here there's a foreign key. Sales ID is a primary key of this table. Product ID is a primary key of this table, but product ID is a foreign key in this table. By the same way, there is here one more foreign key. Category ID, it is a foreign key in this table, but category ID is a primary key. Foreign key is telling us, for example, if I want to transfer data from this place to the category master, for example, I want to transfer my data, let's see from here. Think this database structure and this database structure exactly the same. Now I want to transfer all my categories from this database to this database. Yes. I want to transfer this data, all these categories, product, sales, and customer to this database. In this database also I have category master, product master, sales, and customer. You can change for example, you can tell product instead of product master, you can tell product stage table, but same structure. Sale stage table, customer stage table, category stage table. You want to transfer all data in these tables to this place. When you transfer, can you transfer from here to here directly? You cannot transfer because of the foreign key constraint. Foreign key constraint is telling us what? In the SQL Server or database system, we have 6 constraints. First of all, understand what is the constraint. Today's we should consider if you want to transfer, if you want to copy exactly one data from one database to another database, there is an important constraint, foreign key constraint. Yes, it is important for us today. But to understand the constraint, let's revise them. What is the constraint? Not null constraint means if, for example, if you set this first name as a not null, you cannot leave this place empty. Let's see one example. Copy. Now I want to make two table. Let me do one database. It's called temp. And on the temp, I want to execute one query. This one. If you look at here, I have how many constraints? Not null constraint I have. After that, I have primary key constraint. After that, I have, you should know this constraint from the last year. Yes. Primary constraint, not null constraint, check constraint, default constraint, again, not null constraint, and foreign key constraints. We have 6 types of the constraints. Yes. Let's execute. And then when you look at here, we have some tables. For example, payment. Let me try. For example, payment ID is a 1. Amount, look at, on the amount, there is a 1 constraint. What is telling this constraint? Amount should not be negative value. Look at amount, check constraint. There is a check constraint means is a rule. We can tell constraint as a rule. For example, there is a one rule here. It is limiting our behavior. For example, it is telling you cannot enter one amount less than 0. This means you cannot enter 0 value. Let's try to enter 0 value to that place. For example, minus 100. Reason, for example, school fee. Date, for example, 10, 20, 19, 2019. It will tell me check constraint. There is a check constraint. It is telling this constraint will not allow us to enter this type of the value. And you should make correction. For example, you can tell instead of, if you enter this value by mistake, you should make correction. Now, when I click, there is here another constraint. Let me correct it for now. Later I will explain. Now, look at check constraint is working now. Yes. On the check, there is a constraint. Also, what was the primary key constraint? Let's check this one, primary key constraint. Here also there is a payment ID as a primary key constraint. For example, if I will enter here another number, for example, textbook. And on this one, it will tell payment ID. Look at payment ID. It is a primary key constraint. Yes, payment ID here has a primary key constraint. This means you cannot leave this one empty. We told primary key must be entered to system. Yes, let's enter one value. 1. Again, it will give problem. Why? Again, primary key constraint. Also, primary key constraint telling me, okay, it should not be empty, but also it should not repeat. Yes, it should be unique. You cannot give 1 because you have already used 1. You should use here 2. Different. Now, look at here. There is a constraint here. Primary key constraint. Check constraint. So we are interested today with foreign key constraint. What is the foreign key constraint is telling us? Foreign key constraint is telling us you cannot enter here a, let's see, child. What is child? For example, in this design, we have two tables, student table and payment table. We can call this one as a master table. This one is a child table, or parent table, parent table, child table, or primary table, secondary table. What does it mean? In this table, look at, in this table, there is a student ID. Look at student ID. This student ID is a foreign key. Foreign key. Student ID in this table is a primary key, but in this table is a foreign key. Foreign key is telling us if there is no parent, if there is no parent, you cannot enter record to this place. For example, let's do. For example, I want to tell who did this payment, which student make this payment. One first student did. But it is telling foreign key. It is telling there is no like that student. Let's see if there is like that student or not. Because this table is empty for now. Edit and select. Okay, in this table, nobody entered. Yes, that's why there is no number 1 ID student here. That's why if you try to enter this student to the system, it will not allow. This is a child. Yes, it will tell there is no like that parent in this table. You cannot enter. First of all, if you should tell what is not 1. For example, if I should enter 1 here. First name, for example, Ahmet. Can. For example, Istanbul. Country, Turkey. Birth date, you can give, enter any value. Let's enter second student here. Kyrgyzstan. Now we have two students, Ahmet, or two customers, Ahmet and Dastan. Ahmet is a number 1. Now I can enter this record easily. Yes, this payment done by Ahmet. For example, I can tell this one. I cannot tell this is 3 because it will tell there is no like that student in table. That's why this enter is not valid. Who's telling this one? Who make that check? Foreign key making this check automatically for us. Yes, there is no number 3 student in table. You can, for example, if you want to make, if you can enter here only 2 value, either Ahmet or either Dastan. Let's make this for Dastan. If you enter is Dastan, it will be okay. This means if there is no parent, you cannot enter this record in the count of this parent. First, if you should enter here 1 record, after that, for that record, you can enter a new record in this place, foreign key. That's why, for example, now, if you want to transfer For example, if you want to transfer your data from here to here, yes, he has category ID here, yes. That's why it will not allow us to transfer. In that case, what is the one of the simplest solution? This one. This is a very important point in this one. Our solution, this one. I am designing, look at, I am not making any relationship between them. I am making same structure. Instead of customer master, you can tell stage customer, stage master, stage category, and also you can call it stage sales, but doesn't matter. Here it is called sales, doesn't matter name. I am not defining in our design, look at, I am again, we are doing same things. Now let's do sales, copy. Now I want to design here query. Look at, you are in not master place. You should be careful on the master place. Again, I am making one shopping stage database. Shopping stage database. We have called this database shopping stage database. And then I am making stage category master table. This table is exactly the same with this table if you look at. Let's look at. Category master. Category master, look at. In category master, let's look at the category master. Category master, look at. Category ID. Small int, small int. And here in the operational database, it has primary key, but it is a temporary data. That's why you don't need to add primary key. Yes, you don't need to add primary key because we will not connect this. This table will stay inside the stage database, will not relate it with another table. That's why we will not use relationship. If you don't use the relationship, you don't need to use primary key and foreign key. Yes, there is no primary key here. Look at this product master. Product master, you can give to differentiate different name to your table, but exactly same design. Product ID, product ID. Here in the operational database, we have primary key field, but in the temporal database, we don't have primary key field again because we will not relate this table to the another place. Yes, another table. And in this table also we have foreign key definition. Original operational database, we have foreign key definition, but here we don't have foreign key because we will not relate this one to any table. And now let's run this one. But there is one problem. Shopping stage DB is already designed here. Yes. That's why let's make it 2. Second. Or let's, okay. And then again, here we should do make correct 2. Shopping stage database I have already implemented in this my table, my system. Now I want to insert this one. Look at, in this design, there is no primary key and there is no foreign key. Yes, foreign key. Be careful. What is the foreign key? If database contains foreign key constraint, it can raise error related to the order of the operation or that performed against database. For example, loading child records before loading the related parent record can violate constraint and cause error. This means you cannot load child table before parent table. Yes. You can tell now this solution. What is that solution? We can tell like that. For example, this which table is a child, which table is a parent. This is a child. Yes, because it has foreign key inside it. Foreign key. This is child. You can load first this table. Yes, this table. After that, you can load this one. Yes, but you cannot load this one. Why? Because this is a this is a category ID is a child. Yes, first you should install this. You should load this one. But you cannot not this one because it is parent. Yes, it is a mixing. Which one you will insert, load or not? You cannot load one by one. Yes, but if you remove these relationships, if you remove in your new design, in the stage table design, in the stage table design, we will make this system exactly the same schema, same structure with operational database, but without connection. Yes, let's run, execute. And now we have done one shopping DB, stage DB2. Inside it, we have some table, but there is no relationship. Now, let's see them. It is done or not. Refresh. Shopping DB, yes, it is done. Let's see. We have this table, sales table, stage category table, stage customer table, stage product table. We have this table all. And let's look at the diagram, how it is diagram, how, and if you look at, there is no any relationship between the tables. Now, what can you do? You can do this one. Let's open one place here. And let me find my shopping original database, operational database. This is the structure of my original database. Yes. Now let's take this one. Now what can I do? For example, I can load every data from here to here directly. Customer, category to category. Yes. I can load every data from product to product. I can load every data from sales to sales directly. Now I can load from here to here directly, one by one, in any order. Or you can install first, or you can load first this table, any table, customer to the customer. After that, sales to the sales, category to category, any order. You can one by one, without making any trouble. You can load every data from here to here. But if this is a operational database, as this is a temporary database. But inside the temporary we told operational database structure exactly same with should be same with operational database, because all states from this column will come to the this column states. Yes, structure and their data type should be same, but only you should ignore in the temporal place this relationship. To ignore these relationships, you should not define in this temporary table design any primary and Any primary and then any foreign key. You can ask this question now. If you don't have primary key in your table performance, your database performance will go down. Yes, it is a one problem now. In this database, you have good performance because you have primary key and foreign keys. They will increase your performance of database. But here, there is no primary key and foreign key defined. Performance is this database will work slow. Yes, you can think like that. Yes, but we thought this is a temporary place. For example, if you want to analyze your data, look at this point important. If you want, it can be exam question. It can be exam question. I hope you are taking notes. For example, if you want to, this database is an operational database. Every 24 hours it should run. Yes, it should be run. 24 hours it should run. If you shut down this database, what will happen? Your online business will shut down also. You cannot make online business anytime. Yes, if operational data, if you shut down this system, you cannot run your business, online business. Yes, online working. This is 24 hours. This is working, but this is only work when you need analyze, and then it is a business rule. For example, if you want to see daily analyze, daily report about your business, sales business, what can you do? For example, every day, every midnight at 12 o'clock, you can copy data from here to here. Yes, after that, when you copy, you can copy all data from morning to midnight, all data collected or accumulated in this place. You can bring your data, and after that, we don't need this database anymore. This database can continue running in the system. But this database, how much amount of the data it will keep inside it? Only 1 day data. Inside this database, there is a 1 day data. When you analyze, so when you clear our data, when you make some, if there is if you want to make clean, if you want to clean your data, you can clean. If you want to transfer your data, transfer. When your data is ready, you can upload from here to the data warehouse. Yes, we can upload from here. We can upload our data from temporal to the database. Yes, it's finished. Function of this database finished, and then inside it there is a daily data. Another day, your business running and accumulating, collecting some sales, new sales, and after again midnight, you are transferring only 1 day data, second day data to this place. And first you are deleting the previous day data from here, temporarily because this place, and then you are bringing second day data. Another day again, you are deleting the second day data, temporary data here, and you are bringing the third day's data. If your business is required daily report like that. If your business requires weekly report, what can you do? This operational data runs all weeks. After that, at the end of the week, you can transfer your data from here to here. Only 1 week of data, 1 week of data. Yes, not all data, 1 week of data, or last week of data. Inside it, this means size of this database is not increase. Yes, because if you need daily report, inside it there is a 1 day data. If your business requires weekly report, it contains only 1 week data. If your business requires monthly data, inside it there is a 1 month data. If your business requires yearly data, it will keep 1 year data. But this database will grow up every day, every month, every year, year by year. It will always grow up. Yes. That's why this data, for example, after 10 years, this database will have maybe, for example, billion records inside it. That's why performance is very important. We cannot sacrifice from primary keys and then foreign keys and index fields. We cannot sacrifice in this design. Yes, to design this one, you should properly identify primary key field, because primary is an index field also. Foreign key also as a kinds of index, yes, index field. And then you can add extra indexes to increase the performance of this data. But here you don't need to use any single index, primary key and foreign key, because this data never will grow up much. It is according to your business day. It may contain 1 day data, 1 week data, or 1 month data, or 1 year data. Yes, because none of the business, you cannot see 10 years report. Yes, none. There is no like that business. If there is one business running, mostly they will look daily report. If it is some important business, they need daily report. Some business they require weekly report. Some business they are requiring monthly report or quarterly or yearly reports. Yes, that's why this database will not grow up much. That's why in this database, by the sake of the loading our data easily from here to this place, without getting any problem, we can sacrifice primary keys and foreign keys, and if you have other indexes, you can all cancel all indexes in your system. I hope you understand why in this stage database you don't need primary key and foreign key. If you put primary key and foreign key, what will happen? You cannot load easily one by one from here to here, from here to here, from here to here easily. You will get really headache to load this database. Yes, this is a temporal location. When you bring your operational data this place, after that, if you want to make some clean process on your database, you can make clean process. If you want to make some transformation process, for example, if this database staying in the Europe, you should bring here to your data, and you should change the date format to the European standard to the American standard. Or, for example, measurement done in centimeter, you should convert them measurement in the inch. After that, you can transfer. When you finish cleaning and transformation process in this place, later you can load this data from here to data warehouse. Data warehouse is the next destination, which we will use data warehouse to analyze our database. I understand why you need to design this table in this shape. Again, this database is a relational database. This database is staying inside the relational database system, but we are not going to use any relations. And exactly your operational database design structure, columns and their types exactly should be same with this stage table. Do you have any question up to now?